So I'm Evan Bollig, I'm with AWS. I now have about 15 minutes of your time to talk about AWS and the updates that I wanted to share with the Spack project. Things that I'm really excited about and things that, the messaging I think you need to hear going into the rest of 2026. So long and short of it is thank you, I'm done, right? No, seriously, thank you to everybody in the audience. Thank you to the entire Spack project and to all of HPSF. We couldn't do a lot of what we're doing today on AWS without your support, your help. And I want you to hear that. I want you to know and feel the impact that you're having. Because sometimes when you're working on projects like this, especially in open source, you might not register how impactful you are in your decisions. So when I work with customers, they always ask, you know, how do we do it on AWS? Oh, I'm worried about cost. I want to save money. You know, I want to break free of a scheduler, a queue that I'm stuck in, and I need to do things differently. Okay, so we always go into working with our customers looking for this measure of value and the measure of success. And when I look at HPSF and the three prongs of thrust that we're working on for performance, portability, and productivity, that is exactly what we're measuring with all of our customers. All right? Just for the Spack project, I want to share an anecdote here. So I have a customer that has a Julia application, and this version of Julia that they're stuck to is 1.5. It's a little outdated. Internally, that version of Julia binds against LLVM 9 and OpenBLAS, I forget which version. But these are, both of those internal dependencies go pre-built with the distribution of Julia, and they only support up to Zen version 2, okay? When a customer comes to AWS and we have over 1,000 instance types to choose from, they say, great, I've got portability in my application. I'm just gonna choose the next instance type family, the next generation. And so they'll do something like, you know, we've got our HPC 8A, which is the new AMD Turin processor, or they'll go for the M8 AZN, which has an overclock or higher, 5 gigahertz clock speed. And they'll say, well, I'm not getting the same performance boost that you're promising when you say, you know, that it'll be 42% better memory bandwidth or 40% higher performance. We're not seeing those numbers. Help us understand why. And it comes down to those dependencies that are built into the software, that the language itself is holding you back to Zen version 2. You're not using the latest functionality that you could out of this hardware. So you're only gonna see this like organic delta based on clock speed or raw memory bandwidth, or you know, a small, like the cache size might benefit you a little bit. But if we really want to show those end users, those customers, extra value out of the latest generation hardware, we need a project like Spack to go build the new binaries that can take advantage of those features. And by the way, swapping out LLVM and OpenBLAS in Julia can be complex, but Spack can simplify that, right? That's the whole backing logic behind the DAG and having the concretization. One of the news items, this is a personal thank you to Harman. We, for a long time, have fought this misperception that ECR is not OCI compliant, but it is. We just worked with projects like Spack, which didn't speak to ECR the way that it was asking to be spoken to. So with a very small pull request, Harman was able to get full ECI support for Spack against our Elastic Container Registry. And this means that you can benefit from things like deduplication, automatic scanning, ECR, I mean, any registry really solves all of the management controls. And then we also have pull-through cache. So I can register an ECR registry that will mirror the public binary cache from Spack. And it will only pull in the binaries that I need, and then it holds those in my account. So I get faster access to those binaries anytime I redeploy infrastructure. And that works also with GHCR, Quay, any other type of registry, you can do a pull through cache. Now, a word of caution for anyone who wants to go out and do this, the Spack community and the Spack CI, it's fairly sophisticated. And if you look at the cost difference between S3, just bare S3, and ECR, the value of the ECR service is evident in the cost per gigabyte, right? So for 20 gigabytes of storage, the delta in price is really the S3 standard versus the ECR. But that's not where projects like the Spack binary cache see the pain, right? That it's not the storage that hurts, it's the transmission out. And so when you look at like a terabyte egress from the bucket that is S3 or the backing ECR, you're way higher in terms of cost. So you should be focusing your efforts on cutting those costs instead, right? And the way I try to hash this out with my customers is, why spend a month of effort trying to save the pittance when you could go after where it really hurts, right? So just go straight to the simple thing to do, and that's ECR. And then you've got a consistent cache for a consistent registry for all of your binaries, all of your mirrors, all the packages that need to be staged to move data into your builds. All of that is in an OCI registry. And then you can focus on optimizing with CloudFront and other services, how you're doing your distribution outside of that. One of our groups, the Center for Quantum Computing, actually drove this need for the ECR support. And I want to just give them a shout out for being a heavy Spack user. And they participated last year at HPSF, couldn't make it this year, but they wanted you to be aware of some of the updates on their project, that they're actively leveraging Spack Containerize, they're actively leveraging the ECR support, and they continue to use Spack as like a core dependency in their project. Now, other news items. For storage. I know for the Spack CI, we use a lot of S3. When we serve the Spack CI results, the binary cache, down to our users, that needs to land in a file system. So a feature of our FSX portfolio that I'm really excited about these days is the introduction of S3 endpoints on top of managed storage. What does that mean? Well, on one side, you interact with a file system that's OpenZFS or NetApp ONTAP, and it's POSIX. Users just directly access it, read and write in their code. On the other is an S3 endpoint. So to the world, it looks like a bucket, and you can push and pull data, and it all arrives in the same storage footprint. It's hugely valuable to meet users where they're at, right? And then a second feature that is fascinating to me is intelligent tiering. So FSX for Lustre, it's a managed Lustre high-performance file system. We have always had this ability to tie that storage to S3 buckets and do lazy loading of data into the file system itself, into the Lustre layer. But we've recently added intelligent tiering support. So instead of the entire file system being built out in SSD and an active file system, we actually offload object storage in the layer below Lustre, below what's presented to our customers, to S3. So it's benefiting from all of the scale of S3, and it also benefits from lifecycle policies. So you interact with it as a high-performance file system. Behind the scenes, it turns into an S3 storage, and then data gets automatically lifecycled down to archive, and there are huge cost savings that go with this. So take a 126 terabyte file system, for example. It used to be you would have to over-provision the file system to handle the 126 terabytes that you need to store. With intelligent tiering, you only pay for what you store, right? I mean, you pay for the caching metadata tier, but then the bulk storage behind that is what's charged. And so you've got a 25 terabyte cache, a 126 terabyte file system and storage, and the total cost per month goes down almost 80%. Okay, So for the Spack CI and presenting to users and other things like that, I think you start looking for opportunities like this where you can cut your costs and still leverage known technologies like S3. On the orchestration front, AWS is continuing forward with parallel computing service. We've grown that so that now we can support capacity block reservations. So as you submit jobs to the queue, they're held using a maintenance reservation in the queue. So it's not forgotten work, but it's held by the managed scheduler. And then when the capacity block becomes available, all of those jobs will flush through. So this is a mechanism that allows our customers to leverage GPUs, get them as a capacity block reservation, and they can get them at discount from the on-demand price using a reservation, and then they can bring all their data spooled together and flush it through in a single pass. The service is also HIPAA eligible. We're working on FedRAMP, and there are other benefits too, like it manages the Slurm accounting and has CloudWatch integrations for logging and telemetry. On the EKS side, we've expanded support for AWS Batch. So it used to be you could submit batch jobs directly to EKS. Now those EKS nodes can be hybrid. They can literally go wherever. Rules around how you work with EKS hybrid, but the ability to farm out tasks as batch jobs instead of defining them at the EKS pod layer. There could be some potential here. One other note here. We added support for seekable OCI into EKS. And I know that's one area where the converged computing team out of Livermore was focused for research applications. Could be some benefit for Spack Containerize to build those SQL OCI containers. Shout out to Vanessa in the Flux team for getting Kubeflow Trainer to adopt Flux. That puts HPC closer to our AI ML counterparts. I think any type of project like this really helps everybody in AI ML adopt our best practices. I'm really excited about this one. Another shout out to Samir for the E4S project, actually the whole team at E4S, for pushing AWS supported, so they've been for a while building images for parallel cluster and PCS that come with the E4S toolkit predefined. And we've shared that message with some of our other marketplace partners. And Center for Internet Security adopted the same mentality that it's better to build AMIs that are ready to roll on parallel cluster and PCS than to ask users to build it themselves. So they're now building pre-built AMI for parallel cluster and EKS. It lives on their hardened images page. You can start from those and then add your applications on top. And this is a way that we're trying to hold a higher bar for security. Real quick, I just want to call out, there's been a lot of talk about agents today. One area I'm seeing customers adopt agents is in a red teaming mode on their Git repos. So they'll put an agent audit down, like when you commit or you make a pull request, it'll automatically respond with guidance on how you can address bugs, what the risk factors would be, and just draw awareness, not actually fix the code, but just draw awareness to the developers so they know where they're supposed to put their effort. And then finally, a call to action. I'm hearing from customers quite a bit that GitLab is not always an option. And if you look, and I pick out on Jacquemart and Spack CI here in the top right, they assume GitLab to exist, but customers can't always afford it, or they are not able to get it through the procurement cycle for many reasons. So the community should try and build an alternative. I don't want to see it go away. I just want an alternative. And what we're looking at, it could be GitHub alone, but I think GitHub currently has a limitation that prevents us from doing it because we have a requirement for dynamic child pipelines, and I don't think GitHub can support that yet. So if you know any different, please let me know. I think we also have to think about CI as a like Spack or Spack CI as a component within a larger environment CI. So your infrastructure could be changed as code as well, and we need to track versions of distributions for the end users. And I think that's where the SBOMs come in. I think there's going to be a lot of value out of some of the other efforts in the project. So with that, I just want to say again, thank you to you all, because we don't have the expertise that you bring, and we love working with you and seeing the way that you can benefit us and we can benefit you.
Okay, we have time for about one question.
Go on. Gabe?
So I'm going to answer on behalf of Ryan because he's not here. So there is support now, or maybe it will be with 1.2, but it's in develop, I'm pretty sure, where you can plug in essentially a way to generate whatever CI you want. So yeah, it'll generate GitLab by default, but I think Ryan's making it more pluggable. So that might be an interesting thing for AWS to do, is get it to generate like code pipeline,
so
or something like that.
We have been using code build. What we found, at least in our experience, is that at the top level, when you want GitHub to farm out to different builds for each package, that's the part where it breaks down. If you just have code build, so you could do a code build runner from GitHub where code build goes out and builds the entire environment, that works. But it's the ability to go back and track down an issue for a single package and debug it and to see the farm out of all those separate projects. That's not there yet.
Okay, thank you, Evan.